Very good morning to everyone. Welcome back to my YouTube channel. Let's learn with Dr. MJ. This is Dr. Moumita Ghosh, and today I will discuss independent events. So here I will discuss independent events. Independent events means suppose I am considering two events, event A and event B, such that they don't have any impact on the occurrence of the other. So by definition, I will say an event A is said to be independent of another event B if the probability of occurrence of one of them is not affected by the occurrence of other. Here is the mathematical definition. Probability of A intersection B is equal to probability of A into probability of B. We can see that probability of A intersection B. Probability of A intersection B, what does it mean? What is the probability that both of the events A and B are occurring simultaneously? And it results in like multiplication of individual probability. So this is the independence. They don't have any impact on the occurrence of the other. And let's derive the definition from the conditional probability. Now I have from conditional probability, probability of A given B is equal to probability of A intersection B divided by probability of B. Now if I put probability of A intersection B is equal to this, as I know A and B are independent of each other, then I come up with this thing. So probability of A intersection B is equal to the probability of A. It's showing that first of all, from the definition of conditional probability, we have understood that it's giving you what is the probability of occurrence A given that the event B has already occurred. Now we can see that the event B has no impact on the occurrence of event A. So that's why it's independent events. And statistically, an independent event is said to be independent of another event B if the conditional probability of A given B is equal to the individual probability of A. The unconditional is not the right way of talking. Let's say individual probability of A. So now we know formula for conditional probability, formula for independent events. So let's solve these problems. In a university campus, 20% of the students participate in research club, that is my event A. 80% students participate in sports activities, this is my event B. Now participation in research and sports are independent given in the problem. The question is, what is the probability that randomly selected student participates in both? Participate in both means I have to calculate probability of A intersection B. And I know the formula. If they are independent, it will be probability of A into probability of B. Next thing, what is the probability that a student participate at least one of the two activities? Whenever it said at least one of the two activities, it means it asked me to calculate probability of A union B. Clear? So let's see the answer. So probability of A from the percentage calculation, I have 20% means 0.2. Probability of B is 80% means 0.8. Now probability of A intersection B is equal to PA into PB. So I have this. Next thing, probability of at least one of the two activities means A or B, A union B. So PA plus PB minus P intersection B. This is the inclusion principle you already know in discrete maths. So So I have this answer. Next question is, what is the probability that a student participate in sports activities? Means B, but not in research club, means A. So I have to calculate probability that a students participate in sports activities but not in research club. That is probability of B intersection A complement, not in research club. Let's see the answer. B not A. So I have this formula. Probability of this is my event. This is my event B and this is my event A intersection B. So this is my probability of B intersection A complement. This where this is A intersection B and this is the complete circle is B. So I have this result, probability of B minus probability of A intersection B. Next question, what is the probability that a student participates in neither research club nor sports activities? You already have these values. Probability that they participate at least one. You have already this. So neither research club nor sport activities means you have to calculate 1 minus probability of A union B. So this thing, probability of neither research club A complement intersection B complement. So you have this and you got the answer. Next question. In a company, 30% of the employees work in IT. This is my event A. 40% of the employees work from home. My event B. Working in IT and working from home are independent events. It's said in the question. What is the probability that an employee work in IT given that the employee works from home? So I have to calculate what is the probability that the employee works in IT means this. Given that I know the information, I have the information, the employee works from home. This is the thing I have to calculate. And I know that probability of event A is not affected by the probability of event B because they are independent events. So this is my answer. So as per the given information, I have probability of A is equal to 30% means 0.3 and probability of B is equal to 40% means 0.4. Next thing, you know, okay, next problem. In a manufacturing company, 40% of the machines undergo regular maintenance. 25% of the machines are computer controlled. There are two events, a machine undergoes regular maintenance. Let's say this is my event A and a machine is computer controlled. Let's say this is my event B are independent. It's given information. Now I have to calculate what is the probability that a randomly selected machine undergoes regular maintenance given that it is computer controlled, which means a machine undergoes regular maintenance, event A, given that it is computer controlled, A given by B. Now I have the information, they are independent. So this is equal to probability of A. Now what is the value for probability of A? 40% of the machine undergo regular maintenance. So I have 0.4. This is my first answer. Next question, find the probability that a machine is both regularly maintained and computer controlled, which means a machine, what is the probability that A intersection B? Again, I will use this thing, independence. So I have probability of A into probability of B. So 0.4 into, similarly probability of B is equal to 0.25. As I have given 25% of the machines are computer controlled. So this is my answer. Here you have the complete solution of the previous question. Here we come to the end of the first chapter, conditional probability and independent events, and some practice problems are there. Do practice in your home, and I hope that you completely understood the complete chapter. And if let me know if there is any suggestion for me, and I will definitely include those suggestions in my next video. So thank you, and don't forget to like, share and subscribe of my YouTube channel. Let's learn with Dr. MJ.